Hi folks, this is part 2 of the Introduction to Piecewise notes. We're going to look at the third and final part of the notes that says, using the given graph, identify the following. So I have the graph up on the board, or on the screen, sorry, and I also have what we're trying to find on the right side. So it does ask us to find all of these pieces, at least at the beginning, with interval and inequality notation. So we'll start out with interval, and then we will write the corresponding inequality notation. So for the domain of our graph goes from the left side to the right side, which happens to be an arrow here. So for interval notation, that left side is going through an x value of -9. It's an open point, so I'm going to put parentheses. And then the right value has an arrow, which tells me that it's going on and on, never stopping, and it has a behavior of going to infinity, also with a parenthesis. For inequality notation, what that's saying is that all of the x values are being used that are greater than -9. So you can either say x is greater than -9. You could also think about putting this as a compound inequality, putting -9 here, having no upper boundary over here, and then just connecting it with the less than sign. So either one of those would be correct. Your range goes from the bottom to the top. So the bottom part of this graph is right here. It's bottoming out at a -1, 2, 3. And it doesn't have an actual point here. It's got kind of like a ghost of a point. That's an open point. But we are going to say that it starts at -3 with a parenthesis. And then the top part of the graph, all the way at the top, goes through a y value of 5. And that 5 does actually have a point up there, and so we're going to consider that closed. For inequality notation, the boundaries for your y values are -3 and 5. A parenthesis indicates the less than sign. A bracket indicates the less than or equal to sign. The x-intercepts. Every time the graph crosses the x-axis, that's the point that you want to write. And it happens twice here. So if I follow along the x-axis, as soon as my graph crosses, that's the point I'm writing. Here's one of them. That point is -1, 2, 3, 0. And then if I continue, I have another one right here. That point is 5, 0. For the y-intercept, I'm going to travel along the y-axis, and when the graph crosses the y-axis, that's my y-intercept. So it stops right here. That point is 0, 5. So I go on. It says use interval notation for the rest of this. So I need to talk about my intervals. So let me erase my parts here. There we go. And increasing intervals. For which interval is the graph increasing? Remember, if there are multiple intervals, you connect them with a U, which stands for the union of those intervals. So the graph starts off here, and it increases until it gets to here, and it continues to increase until it gets to here. That's when it starts decreasing. So from -9 all the way to an x value of 0, that's where the increasing interval is happening. So from -9 to 0. We don't include those points of change, because here at this point, the graph stops increasing and starts decreasing. So we don't include that point of change. It decreases until it gets here. It starts increasing again until it gets here. And then it stops increasing because it's straight, it's constant after that. So the second increasing interval is from 5 all the way to 10, 11, 12. So from 5 to 12. Again, we're not including those points where change is occurring. The decreasing interval, it's only happening once. So here was increasing, but here is decreasing, and that interval is from 0 to 5. So from 0 to 5. The constant interval is where the graph is flat and straight and horizontal, and that's happening right here. So that starts happening at 12, but it doesn't stop happening. So in interval notation, that's from 12 to infinity. For positive and negative, we want to discuss what happens when the graph is above or below the x-axis. So the part of the graph that is positive, that's the part of the graph that is above this line. Not on this line, but above this line. So it's this section here. It's also this section here, but it's not this down here, and it's not the points that are on that line. So let's see if we can define those two intervals that are positive. It starts becoming positive at an x value of -3. It does its positive thing, and then it goes back to the surface, if you consider this kind of like water, back to the surface of the water at 5. Stops being positive there for a moment. And then it picks back up and is positive from 5 to infinity. It's still above the x-axis from 5 to infinity. Now the negative interval is everything below. So the only portion below the x-axis is this beginning portion here. It starts at -9 and it kind of goes above water, if you will, goes above the x-axis here. So from -9 to -3. The maximum value is the highest point on the graph. And so if we want the highest point on the graph, I'm going to go look up where the graph gets really, really tall, and that would be right here. Think about that y value. That maximum value is a y value of 5. That point happens when x is 0. The minimum value is how low the graph can get. The graph goes all the way down to here at -3. So the lowest y value is y equals -3. It's not included in the graph, but it is the location of that end point, and that point happens when x is -9. Finally, we have a few last questions. They're not really interval related, but they are related to finding points. So in f of 0, we've talked about function notation and how this is the x value. So I want you to go find an x value of 0. This is x of 5, 4, 3, 2, 1, 0. Where does the graph cross an x value of 0? Well, it crosses right here at 5. I want you to pause your video and try the next question, remembering that this is an x value, so go find where the graph crosses an x value of -5. Hopefully you were able to find an x value of -5, and you can see that the y value is happening right here at -1. So now we want to find x when y is 1. And so when y is 1, that's a y of 5, 4, 3, 2, 1, right here. So the graph crosses this line several times. It crosses it here, here, and here. And none of those times are times where the graph crosses at a nice, pretty point. And so now is when we need to use our piecewise formula to figure this out. So the graph does not cross a y value of 1 in the first piece, so I'm not using this first function. The y value does become 1 in the second piece, so I'll be using this function, this equation. It happens again in the third piece, so I'll use the third equation. And it happens again in the fourth piece, so I'll use the fourth equation. And what I'm doing is I'm wanting f of x to equal 1. So I'm going to create an equation where 1 equals this equation, 1 equals this one, and 1 equals this one. And I'm going to find all the different x values for which this happens. So Let me move this down so that I've got a little bit more space. I don't have a lot, but I do have a little. So first equation, I have 1 equals 5/3 x plus 5. 5/3 x plus 5. So if I were going to solve for x, thinking about peeling layers away, the outermost layer is plus 5, so I would subtract 5. I have -4 equals 5/3 x. And if I were going to remove the 5/3 from the x, I would divide by 5/3. But dividing by a fraction is the same thing as multiplying by its reciprocal. So I would multiply by 3/5. Oop, I'm writing off of the screen. There we go. So x equals, we've got 3 times -4, which is -12. And we've got 5 times a denominator of 1, which is 5. So there's one of the x values. Second x value comes from the second equation that we are referencing. So we need to write the equation 1 equals -x plus 5. So in that piece, the way that I would solve for x is to subtract 5. So I'd have -4 equals -1x. And to get rid of the negative, I divide by -1. So x equals 4. There's another x value where the graph is being crossed. And then finally, with the third equation, I should have 1 equals 2/7 x minus 10/7. So 1 equals 2/7 x minus 10/7. Now I know that they're fractions, and I know that I'm going to need to do some fraction addition and subtraction. So I'm going to make everything have a denominator of 7. This 1 can be written as 1/1 or 2/2 or 3/3. I'm going to turn it into 7/7. Because the first step would be to add the constant. So 7/7 plus 10/7 is 17/7. And just like in the previous problem over here, if I wanted to divide by 2/7, that's the same thing as multiplying by the reciprocal. So x equals, I notice I have a 7 on top and a 7 on bottom. Those can cancel. So now my numerator is 17 and my denominator is 2. So there are 3 x values that we should have when y equals 1. We should have -12/5. We should have 4, and we should have 17/2. So now you have an assignment to complete. Please reference your notes so that you can feel a little bit more comfortable about the material. And when I return, if you have questions, don't hesitate to ask. Y'all have a great day. Bye, guys.